Huawei is doing a lot of radio access technology. Unlike, say, image processing or language processing, where the internet today provides huge sets of data, in a radio access network, the data is rather limited. And this means we need machine learning methods that can learn quicker or with less data.
The data we get from our simulations and from the real systems that we deploy is usually not enough to train big data models in the traditional sense. To solve this issue, we need to find a new type of techniques to work with this small amount of data.
So the challenge is that, for deep learning to work, you need a lot of labeled data. And this is very hard to come by. So usually you just have a small data set of labeled data. But you can't really learn on that.
We were given two data sets, one of them very big one containing unlabeled images, and the other one was a smaller one containing labeled images. And our task was to propose a machine learning algorithm that would use unlabeled images in an unsupervised approach to extract useful representations in order to make a classification using the labeled images. And then that was tested on a third data set that was independent from those two.
What my group tried to do was stacking a few RBMs on top of each other to extract features from the unlabeled images and then put on top a classification layer where we train with the labeled data.
We've worked a lot on perfecting the little details, why we use exactly certain parameters or certain types of loss functions and whatever.
And we thought about where the data is coming from, because the unlabeled data set will be images of something much different from the labeled data. This is something we took into account when we built our model. We built it so it didn't become too specific for the unlabeled data.
We proposed a solution where it was a threefold one. It was based on 3 papers from the last 3 years. The main idea was to use self-supervised learning, providing the network with a task from all the unlabeled data, coming up with a task that we can kind of make a classification out of it. Basically, each of the images, we rotated it in 4 different angles, 0, 90, 180 and 270. And then our network had to predict what's the rotation angle. And in this way, our network finds a useful representation. It's actually encouraged to learn semantic information from the image, as well as pose, as well as object class, etc. And then after that, on top of that, we train a classifier.
The winning solution today, they were trying to predict how an image was rotated. And both I and the judges thought that this was a really interesting solution and that they had really tried to find something novel.
We have never implemented similar project before. That was the first time. We knew about this paper from research point of view, so we knew that these methods exist. Today we applied them for the first time.
The solutions that they come up with, maybe not exactly the results themselves, but the method they use, the papers they found, and how they approach this problem in general. So it's going to be really interesting to see, how we can integrate this in some of the research that we are doing in our team.